Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Today we're doing something different, a deep dive study guide for what might be the most important certification in platform engineering right now. But first, let's hit the news.
Decathlon just announced they've switched from Spark to Polars for their data pipelines. The retail giant says it's cut infrastructure costs significantly while improving performance, another sign that the REST-based data ecosystem is maturing fast.
Speaking of maturity, the State of Platform Engineering Survey 2026 is making the rounds. Some interesting data points about salaries and team structures we'll probably cover in a future episode.
And there's a good piece on business SLOs floating around. The gist, your SLOs should map to business outcomes, not just technical metrics. Revolutionary, I know.
All right, let's get into today's main topic, the CNPE, Certified Cloud Native Platform Engineer Exam. Alex, CNCF keeps adding certifications. There's over a dozen now. Why should anyone care about this one?
Because it's fundamentally different. CNPE launched November 11, 2025 at KubeCon Atlanta, and it's the first hands-on platform engineering exam in 5 years. CKS dropped in 2020. Since then, everything has been knowledge-based.
Wait, hands-on meaning what exactly?
Meaning you're in a Linux remote desktop for 2 hours with 17 tasks to complete. Real clusters, real tools, real infrastructure. No multiple choice, no true-false. You either build the thing or you don't.
17 tasks in 2 hours? That's roughly 7 minutes per task.
And here's where it gets interesting. I've been reading beta tester feedback. One person said, quote, "I estimated my score at 29% and chose not to complete," end quote. Another called it the hardest CNCF exam ever released.
29%. That's brutal. But let's back up. Where does CNPE fit compared to the certifications most listeners probably have?
So if you picture a pyramid, at the foundation you have CKA, Certified Kubernetes Administrator. That's your cluster fundamentals. 83 domains, deploying workloads, networking, storage, the baseline.
Most senior platform engineers knocked that out years ago.
Right. Then you have CKAD, the developer-focused one. Application design, configuration, multi-container pods, some overlap but different focus.
And CKS?
CKS is where it got serious. Security, supply chain hardening, runtime security, network policies. Until now, CKS was considered the hardest hands-on exam. 2 hours, about 15 to 20 tasks depending on the version.
So CNPE is harder than CKS?
Significantly. CKS tests whether you can secure a cluster. CNPE tests whether you can build an entire platform. That's the difference between a security engineer and a platform architect.
Let's talk about what that actually means. What does CNPE cover that CKS doesn't?
5 domains. First, GitOps and continuous delivery at 25%. Not just deploying an app, but implementing full GitOps workflows, progressive delivery with canary deployments, automated rollbacks based on metrics.
So Argo CD, Tecton, that kind of thing?
Exactly. You need to know application sets, sync waves, app of apps patterns. If you can't configure a canary rollout with automatic rollback on a metric threshold breach in under 7 minutes, you're in trouble.
That's specific. What's the second domain?
Platform APIs and self-service, also 25%. This is where CNPE really differentiates. You need to design custom resource definitions, build self-service provisioning workflows, understand operators.
So cross-plane backstage?
Both. Cross-plane compositions, XRDs, claims, backstage software templates. The exam might ask you to create a CRD for database as a service, wire it to a backstage template, and verify that a cloud-native PG database actually provisions.
That's a full-stack platform engineering task, not just Kubernetes operations.
That's the point. Domain 3 is observability and operations at 20%. Open telemetry instrumentation, including auto-instrumentation for Java, Python, Node, configuring traces to Yager, metrics to Prometheus, building Grafana dashboards.
And open cost for showback?
Yes, FinOps is in scope. Resource attribution, cost allocation. If you've never set up OpenCost in a production environment, that's a gap to fill.
Domain 4?
Platform architecture at 15%. Best practices for networking, storage, compute, multi-tenancy, resource optimization, gateway API versus ingress.
Carpenter knowledge?
Helpful but not required. They're testing architecture decisions more than specific autoscaler implementations. Can you design a multi-tenant cluster with proper namespace isolation, resource quotas, and network policies?
And the 5th domain?
Security and policy enforcement, also 15%. Kyverno policies for guardrails. Falco for runtime threat detection. Shift left security and pipelines.
Not OPA gatekeeper?
Kyverno. They've standardized on Kyverno for policy. You need to know mutate, validate, and generate rules. Blocking latest tags, requiring labels, enforcing resource limits.
So the tool stack is essentially Argo CD, Crossplane, Backstage, Kyverno, OpenTelemetry, Prometheus, Grafana, Yager, OpenCost, and Falco.
That's the core, the backstack. Backstage, Argo CD, Crossplane, Kyverno. Plus the observability trio of Prometheus, Grafana, and Yager, all connected through OpenTelemetry.
Let's talk strategy. 17 tasks, 2 hours. How do you even approach that?
The 7-minute rule. If you're stuck on a task for more than 7 minutes, flag it and move on. You cannot afford to burn 15 minutes on one problem when there are 16 others.
Same as CKA and CKS.
With one key difference, CNPE allows GUI access. You're not just living in kubectl. The exam environment has web interfaces, and sometimes the GUI is faster.
Really? Give me an example.
Argo CD. If you need to verify a sync or check the application graph, the Argo CD UI shows that in seconds. Navigating through kubectl get application and parsing YAML takes longer. Use the tools that make you fast.
What about partial credit?
The tasks have multiple valid approaches. If you accomplish the objective, you get the points. They're not testing whether you use kubectl apply versus Argo CD app create. They're testing whether the thing works.
What's the pass score?
64%. So you need to nail roughly 11 of 17 tasks. With flagging and returning to hard ones, most people suggest tackling easy wins first, banking points early.
Let's go deeper on the technical requirements, domain by domain. GitOps and CD at 25%. What specifically should someone be able to do?
At minimum, install and configure Argo CD from scratch, create application sets with cluster generators and Git generators, implement sync waves so resources deploy in order, set up an app of apps pattern for multi-application management.
What about Tekton?
You should be able to create a pipeline from tasks, wire in triggers for Git webhooks, build a complete CI/CD flow that runs tests, builds an image, and triggers a deployment. Tekton is the CNCF standard for pipelines.
And progressive delivery?
Argo rollouts, canary deployments with traffic splitting, analysis runs that check metrics from Prometheus, automatic rollback when latency exceeds a threshold. This is where it gets tricky because you're integrating multiple systems.
Practice task?
Here's a realistic one. Configure Argo CD to deploy an application from a Git repository using a canary rollout strategy. The rollout should promote automatically unless P99 latency exceeds 500 milliseconds, in which case it should abort.
That requires Argo CD, Argo rollouts, Prometheus, and a configured analysis template.
Exactly. 7 minutes. Go.
Okay. Platform APIs at 25%. What's the technical bar?
CRD schema design. Not just applying an existing CRD, but creating one with proper validation, defaulting, and open API schema. Bonus if you can wire up a validating webhook.
Cross-plane depth?
Composition functions, understanding how a claim creates a composite resource, which then creates managed resources. You need to be able to debug why a claim isn't provisioning.
What about backstage?
Software templates, using either cookie cutter or Yeoman. The exam might ask you to create a template that scaffolds a new service with all the Kubernetes manifests, wires it into Argo CD, and registers it in the Backstage catalog.
So, end-to-end developer self-service.
That's platform engineering in a nutshell. Developer clicks a button, infrastructure appears.
Observability at 20%. Open telemetry seems to be the center.
OTel auto instrumentation is key. You need to know how to configure the OTel collector operator to instrument a Java or Python application without changing the application code. Pod annotations, the OTel collector pipeline from receivers to processors to exporters.
What about the collector configuration?
Receivers, processors, exporters. The exam might give you a half-configured collector and ask you to add a processor for filtering or add an exporter for Jaeger. Know the YAML structure cold.
Prometheus and Grafana?
PromQL for SLI calculations. Write a query that shows P99 latency by service. Create a dashboard with panels for error rate, latency, and throughput. These are table stakes.
And trace context propagation?
Understanding how trace IDs flow between services. If service A calls service B and the trace breaks, you need to know where to look. OTel context propagation is testable.
Platform architecture at 15%. What's the scope?
Multi-tenancy patterns, namespace isolation with resource quotas and limit ranges, network policies that prevent cross-tenant traffic, maybe a question about when to use multiple clusters versus multiple namespaces.
Gateway API versus ingress?
Gateway API is the future, but both are in scope. You should be able to configure an HTTP route with path-based routing, ingress with TLS termination.
Storage considerations.
Dynamic provisioning with storage classes, understanding persistent volume claims and how CSI drivers work. Maybe a question about choosing the right storage class for a stateful application.
Security at 15%. Caverno and Falco.
Caverno policies are the big one. You need to write cluster policies that validate, mutate, and generate resources. Create a policy that blocks any pod without resource limits. Create a policy that adds a default network policy to every namespace.
And Falco?
Runtime threat detection. Understanding how to write Falco rules or modify existing ones. Create a rule that alerts when a shell is spawned in a production namespace. Integration with alerting systems.
Let's talk preparation timeline. Someone listening to this, how long should they budget?
Depends on background. If you're already a senior platform engineer running an IDP in production, 2 to 3 months of focused study. If you're transitioning from traditional DevOps or have CKA but not much platform experience, 4 to 6 months.
What's the preparation path?
Prerequisites first. Validate that you're solid on CKA fundamentals. CGOA for GitOps principles is helpful. CBA for backstage basics. CNPA gives you the platform engineering strategy layer.
CNPA versus CNPE confusion. What's the difference?
CNPA is the associate cert, knowledge-based. It tests whether you understand platform engineering concepts. CNPE is the professional cert, hands-on. It tests whether you can implement those concepts under time pressure.
What about study resources?
The CNCF platform's white paper is essential for theory. Code Cloud has courses covering each domain. RxMy offers a 5-day boot camp for $39.95, including the exam. There are books, Implementing GitOps with Kubernetes by Lyko, Platform Engineering for Architects by Corbacker.
And hands-on practice?
Build a complete IDP in a home lab, the full backstack plus observability. Backstage to Crossplane to Argo CD to Caverno. Open telemetry feeding Jaeger and Prometheus and Grafana. Go from template to deployed application, end to end.
Is there a killer.sh equivalent?
Not yet. Killer.sh is coming for CNPE in Q2 2026. Until then, you're building your own practice environment.
Let's talk career impact. Why does CNPE matter?
3 reasons. First, salary.
Platform engineer salaries are running $160K to $220K. Senior platform architects are seeing $250K plus. CNPE differentiates you for those senior roles.
Second?
Golden Kubestronaut. It's the elite designation for holding all CNCF certifications. After March 2026, CNPE is required for that designation. If you're working toward becoming a Golden Kubestronaut, this is now mandatory.
And third?
Job screening. Hiring managers are starting to ask for CNPE specifically. It's becoming the proof point that you can architect and build platforms, not just operate Kubernetes clusters.
What's the cost?
$445. Includes 2 attempts, which you might need given the difficulty, valid for 2 years. Compared to the career ROI, it's cheap. Any exam day tips?
Read the entire question before touching the keyboard. Use the GUI when visualization helps. Don't fight the clock. Flag and move at 7 minutes. And remember, there are multiple valid approaches. Pick what you know.
Let's synthesize. What's the takeaway?
CNPE isn't just another certification. It's the industry-defining credential for senior platform engineers. The 5 domains map to real platform team responsibilities. The difficulty is intentional because the job is hard.
How should someone start today?
5 steps. First, assess your gaps against the 5 domains. Second, build a full IDP in a home lab with the backstack plus observability. Third, practice with hands-on scenarios, not just reading. Fourth, budget 2 to 6 months depending on your background. And fifth, if you're already doing platform engineering work, the exam is just validating what you know.
The exam is hard because the job is hard.
Exactly. And if you're already doing platform engineering work, you're preparing every day. CNPE just puts a credential on what you already know and opens the door to those 200K plus roles.
For listeners who want more, we'll have show notes with links to the official exam page, study resources, and the domain breakdown. If you've taken CNPE, drop us a comment about your experience. This is still a new exam, and real candidate feedback is valuable.
Good luck to everyone studying. This is the certification that proves you can build platforms, not just use them. Make it count.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.